All right, so if you're working in the JAX world, you've definitely heard the buzz about NNX. It's this new library that's designed to make building models way simpler, a lot more like PyTorch, right? It promises to sweep away all that usual JAX ceremony, but as we're about to find out, theory can hit a very practical and very slow reality when it's time to actually load up a model.
And this is the exact moment where it all gets real. You've built your awesome new model in NX, the code looks super clean, it feels great, and then you slam into this question. This isn't some academic problem, it's the one practical step that turns your fancy code into a useful, working model. So, how on earth do you do it efficiently?
Now you might think, hey, this should be pretty straightforward. And the most obvious solution, well, it does work, but, and this is a big but, it comes with a massive, and I mean massive, hidden cost. Let's dive into the pain of the naive approach.
So here's what pretty much all of us would try first. You just instantiate your complete model. This tells JAX to go ahead and allocate memory for every single parameter, filling them all up with random values. Then, in the very next line of code, you load your pre-trained weights from a file and just overwrite everything you just created. It seems logical, right? But you're doing a ton of work just to throw it all in the trash a second later.
So how much work are we talking about? Well, for a decent-sized 1.6 billion parameter model, this so-called simple loading process took almost 700 seconds. No, that is not a typo. You hit run, you go make an entire pot of coffee, you drink it, and you come back, and you're still waiting. Let's just put that number into perspective, okay? Nearly 700 seconds is over 11 minutes. 11 minutes of just sitting there, staring at your screen, waiting for the model to load before you can even run a single line of inference. In today's world of rapid iteration, that is an absolute eternity. There has to be a better way.
And thankfully, there is. And we're not talking about some small little improvement here. We're talking about a totally different way of thinking about the problem that results in a mind-boggling 700 times speedup.
The solution is all about using a core feature of JAX to our advantage. See, instead of building the entire model, weights and all, we can just trace it. This process figures out the shape of the model, all the dimensions and the structure of the parameters, but without actually allocating any memory or initializing any values. It's like getting the complete architectural blueprint without laying a single brick.
And the result of using this tracing method, the startup time just plummets to less than 1 second. Think about that. We go from over 11 minutes of painful waiting down to just 0.92 seconds. The difference is absolutely staggering.
I mean, this chart just says it all, doesn't it? It's not even a fair fight. On the left, you have this enormous skyscraper of a bar, representing 11 minutes of completely wasted time. And then on the right, you can barely even see the bar for the optimized way. That 700x improvement isn't just a number. It's the difference between a workflow that makes you want to pull your hair out and one that's smooth, fluid, and efficient.
So how do we actually pull this off? It feels a bit like magic, but really it's just a super clever way of using JAX's core design. Let's break down the exact steps you need to take to get this sub-second loading time.
First, we've got to get our heads around the key concept, JAX tracing. You can think of it like JAX doing a dry run of a function. It follows the logic, it tracks the shapes of all the grays as they move through your code, but it skips all the expensive math, the flops, and it doesn't allocate huge chunks of memory for the final values. This gives us all the structural information we need for basically zero cost.
And here it is, the 6-step playbook. Step 1, we trace the model to get its shape. No expensive math involved. Step 2, we split the model's skeleton, its graph definition, from its parameters, or state. Step 3, we flatten that state into a simple dictionary. This makes Step 4 a piece of cake. We can now load the pre-trained weights from our safe tensors file and just assign them directly. Step 5, we merge that now populated state back with the model structure. And boom, Step 6, you're ready for inference. It's a clean, logical process that happens to be insanely fast.
So after seeing that incredible difference in performance, what's the big lesson here? This isn't just some neat little trick for one specific situation. This is a fundamental change in how you should think about loading models, and it should probably become your new default.
The crucial point is this. You should never, ever pay for a full round of parameter initialization that you're just going to throw away a second later. Every time you initialize data only to immediately overwrite it, you're wasting compute cycles and, way more importantly, you're wasting your own valuable time. The goal is to only create the things you're actually going to use.
And that really brings us to the final thought I want to leave you with.
This whole principle goes way beyond just loading weights in NNX. I want you to take a look at your own code, at your own data pipelines, your own workflows, and ask yourself this question: where else am I paying the price for initialization only to discard the result a moment later? Because finding and fixing those spots, that's where you're going to find your next 700x